Hi guys, we are starting a series of liquid simulation in Unreal Engine with Niagara Fluids. In this video, we are going to learn how liquid work in Niagara with the help of 2D simulation, and in other video, we are going to jump into 3D liquid and foam. So without any delay, let's jump into Unreal Engine. I have opened a new blank scene here. So in order to use the Niagara liquid simulation, you need to enable Niagara in plugins. So let's just go to edit. Let's go to plugin. Just type here Niagara and just make sure that your Niagara and your Niagara custom data interface and Niagara fluids are turned on along with Niagara sim caching, because if you want to cache out the sim, you can do with the help of Niagara sim caching here. And then you need to restart your engine, and after that you are ready to use the Niagara liquid simulations. So now let's just close this. Now before diving into 3D liquid simulation, we will first understand how 2D liquid simulation works in Unreal Engine. So let's just go to content drawer here. Let's right click and let's create a new Niagara system. Now as you guys can see, we have a learning content here and we have a Niagara fluid library here. Now Unreal Engine provide us with various templates which you can use for liquid simulation as well as fire and smoke here. You guys can see we are having some liquid simulation presets of grade 2D. Then we have a grade 2D SW particle collision. Then we have a 3D grid. So let's just import a 2D drop here and let's just create it here. Let's just name it to 2D drop. And let's just add our Niagara system NS underscore. And now let's just wait for it to compile and let's just drag and drop it to our scene here. And now you can see if I take it upward somewhat, now you can see we are having this 2D water here. As you guys can see, it's basically having a movement here. We can control all of this stuff. We are going to look at that in a moment. But as you guys can see, it's 2D. So if I goes downward here, you can say it's a flat plane and it's only one-sided here. We can only see from top and we cannot see from bottom here. So let's just go to our top object here. Now, if you are thinking that you can press R and resize it from here, no, you cannot. You need to go to its system properties and then resize it. So let's just create a new level here. Right. Let's just create a basic level. And let's just import our Niagara 2D drop here. And now you can see we got that drop. And now we are seeing something like this here. So let's just double click it here in our Niagara system assets. And now you can see we are getting this thing here. We are having a shallow water emitter and we are having a NS2D drop properties here. So let's just click on this shallow water emitter. And now you can see we are getting this drop here. And you can see here we are having a bottom depth of -50. If you want, you can also increase the resolution here. By default, it's set to 128. You can take it up to 256 also. And now you can see our water quality is improved. So you need to save it. And if I close it here, you can see our quality is improved here of water. So you can see it feels like a pool here now. Let's just double click it again. Now, if you pause this simulation here and if you go back here, you can see we are having a world grid size. So this is where you can resize your grid. So if I take it to 2000 by 2000, now it's a 2D grid. So we are only getting X and Y here. So if I save it again and close this, now you can see we are having a big grid and you can see we are getting the 2D drop effect also, which is looking really good. So this is just a 2D example. So if I double click it again and if I go to emitter properties in my Niagara system, you can see if I click on emitter summary, you can see it is using a collision system for landscape, rigid mesh collisions also. So we are going to look at collisions in next chapter when we are going to create a foam and mist effect. Let's just scroll it down here. You can see we are having a wake size multiplier. So if I take it to 3 here and just save it again, and if I go here, you can see we are getting a small ripples here. So you can increase this or decrease this as per your requirement here. So let's just make it big here. Then you can see we are having a gravity also. We are having a velocity advection method also, and we are having a velocity dissipation also. So if I scroll downwards here in our shallow water emitter, you can see we are having a mesh render here, and we are getting this render from our mesh render. Now, if I go upwards here, there are not much things that you can change here. So as you guys can see, all these parameters are there, but you cannot change much settings here. So let's just close this now, and let's create a cube here. So let's just go to our shapes, and let's create a cylinder here. And now if I take it inwards, you can see our cylinder is in basically our water plane. Now if I move it here, you can see it's not affecting, it's not colliding. So to activate the collision in any object, you need to make sure that you are having a tag of collider. So let's just search for tags here. Let's just add a actor tag here. Let's just name it to collider here. And now if I press enter, you saw that there was a ripple effect. So let me show you again. This was before, and this is when I name it to collider. Just pay attention here. You can see there is a ripple effect. And now if I play here, you can see our cube. You can see our cylinder is moving into our water here, and it's a 2D water. So we are not getting any foam or mist or something like that here. And if I move it here also, you can see how this is working. See, this is looking really good. Now let's do one thing. Let's take another 2D example. So let's again go to our content drawer here. Let's just create a new Niagara system, and let's just have this particle collision here, and let's just create it. And let's just name it to NS for Niagara system underscore sphere or underscore particle collision. Okay, now let's just drag and drop it here. And now you can see we are getting this collision of a sphere here, which is moving here. And now you can see this is looking something like this. Now, if I take my cylinder here, and if I take it outwards or inwards, so let's just take it inwards to something like this. Now you can see this is also affecting. And if I play it here, you can see we are getting this thing. If you move too quick, you will get some jitter effect here, as you can see. So let's just change this properties. Let's just increase this resolution here. So if I double click it here, and if I click on this shallow water collision, you can see we are getting this collider mesh, and it's the collider mesh is set to collider. So that's why we are getting this wave here. And if I scroll downwards, you can see our max resolution is set basically to 512 here. Now, if I again go to my properties of shallow water emitter, you can see it's using a GPU compute sim. So as you know, our Niagara system is using GPU. Don't click on this fix, otherwise your Niagara liquid simulation will not work. If you want, you can have the white water also, but this is a 2D sim, so we are not going to see that much white water. Okay, so there are not much things that you can change into this 2D parameters here, but it is necessary to learn that how you can change the resolution max axis, how you can do the world grid size. So before diving into 3D, we need to make sure to know that how the 2D water works here. So this is how your 2D water works. So now you can see we are getting this thing here. Okay, so this is looking nice. So you can see we are getting this really good ripples and all that stuff. So let's just right click again. Let's just go to Niagara system here. And now we are going to have one more, which is a grid 2D flip hose. And let's just create this here. Okay, let's just press enter right now, and let's just import this. So if I just import it here, and now you will see we are having a 2D plane, and it's emitting some particles here. Okay, they are colliding with each other. So let's just take it somewhat backwards, and now you can see we are getting this result. So this is our emitter, and it's emitting liquid, and the liquid is basically having this boundaries, and it's bouncing back again and again. So if I double click it here, now you can see we are having a 2D flip solver. As I told you, this is not a 3D solver. So if I click on this, now you can see we are having not that much properties, but if you want that your fluid should not collide on this axis, so it's a x-axis. So what you can do, you can just open it on basically all the axes, and now our liquid will not collide. So if I open all the axes here, you can see it's going downwards. Now let's just untick this down here, and now you can see it's colliding here. Now if I untick this boundary left, Now it's going to collide on left side also on x-axis, and if you want on y, you can also do that. And if you want that you want to emit with much more force, you can do that also in your velocity scale. So if I set it to 5, and if I scroll downwards here, you can see that we are having a world grid extent and on maximum cell size. So if I take it to 512, now you can see we are emitting much more particles here into our scene. So if I take it upwards, now you can see this is how it is looking here. And if I want to increase the world grid axis in x direction, I can take it up to 2000. Now you can see our grid is expanding till here. So this is how our 2D So this is how our 2D flip simulation works in Niagara system.